Hi, everyone. Welcome to our Tuesday live stream. Today, we're super excited to welcome Steve Gordon back for another conversation about .NET. Steve, it's great to see you again. Thank you so much for joining our stream. I know it's a little late for you since we are streaming in Mountain Time and you are on the other side of the pond. So thanks, thanks so much for joining us. So I'll hand things over to you in just a moment. Folks, if you do have any questions for Steve, please throw them in the chat. If you have questions about anything related to Elastic, I'll be in there monitoring. So I'm happy to try to address those questions as they come up. So without further ado, I'll hand things over to Steve for a .NET demo.
Cool. Thank you very much, Faith. So for anyone that joined last time we streamed, which was a few weeks ago with Jay, we started building out a very sort of beginner-based .NET application to talk to Elasticsearch. And I'll just briefly recap where we got to. And then the intent of this stream is to kind of carry on and look at the search and retrieval side of kind of getting some data out, having now put some data into an index. So this is pretty much the code we ended up with in the previous session. So we set up an Elastic client here. We do a check to see if an index using this index name here, so stock demo v1, to see if that index already exists in our cluster. We will, if it doesn't exist, then we created the index with a couple of settings and a mapping for properties to say that we wanted specifically in this case the symbol value or the symbol property off of any our stock data objects to be mapped as a keyword. We then created the index. Then we did some data ingestion. So we used the bulk all helper here to basically read a load of data from a CSV file and then store that into the index. And then once that was all done, we added an alias onto there, which we may get to today. We may follow up on another time, but it's often useful to use an alias when you're accessing the data, because it means that at any point in time you can kind of redirect that alias to look at a different index. So if you want to do any kind of data manipulation changes behind the scenes, moving data into a new index with new configuration and new mappings, you can always repoint your client code to that in the future. So that's kind of where we got to. As I say, I think it'd be useful if we kind of had a go at some search scenarios. So I've listed a few that I think are probably common ones. We'll build those out. But if anyone has any questions about those as we're going along, we can always kind of divert a little bit onto those. So the first thing I'm going to do is just prove that the index is primed. So I'm running all of my Elasticsearch at the moment in Docker. We kind of covered briefly how that worked last time, but I've also spun up a Kibana instance this time that's actually sort of talking to that Docker instance of Elasticsearch. And what I'm going to do is just do a cat indices. Always spell this wrong. Should let autocomplete work there. And I think we want v equals true to get the headings. It's a bit ugly on this scale, but basically you can see here as after completing the previous session, we have this stock demo v1 index. We can see that it's got 619 odd thousand documents as a result of our bulk indexing operation. So we've got data in there that we can kind of query. And this console here, this DevTools console in Kibana, I found it really useful if you just want to kind of experiment with an existing cluster and get some data about what's in there, query it, play around with how your search query should be built up. The DevTools in Kibana is a great way to do that. And in this case, we're just using it to verify that we do indeed have an index to work with there. So let's do a quick check. So one of the scenarios that people sometimes want to do is just find out how many documents actually exist in an index. So what we could do is maybe do a count on those documents. And I'm going to do that using I'll always be using the async APIs that we provide. We do provide synchronous APIs on the client as well, more for legacy applications that don't have the possibility of using async. Wherever possible, use the async ones. Just means that your application should perform better because threads won't be tied up waiting for responses from the server. We'll be able to kind of release those threads while we're waiting for responses to come back. So in this case, we're going to do client count async. And let me think here. We could do we could use the fluent syntax here, and we'll say, okay, well, let's count everything in autocomplete's doing quite a good job here in index name. Now, the reason this is squiggly at the moment is that the compiler doesn't know which overload of this count async we want, and that's a little unfortunate and something we can look at improving. But right now, as long as we specify the specific generic type for this, it will work out, okay, we're actually using the overload of this count async method here that takes this fluent descriptor syntax that's quite convenient for chaining complex requests together. But perhaps some of you are thinking that's a bit annoying and it's a bit verbose. So something we could do instead is use what we call the kind of initializer syntax. So if I do count async this time, I'm not going to use the generic one. I'm just going to create a new count request, and there should be a new constructor on this that takes the index name. So this, and I need to await this as well. So these are just two fairly similar ways of doing the same thing with slightly different syntax depending on your preference. So in this scenario and this second one here, we actually have to create the request object ourselves, and we can use its constructor here. But we could, if it had additional properties, we can sort of configure those properties on that request as well, just by standard object creation and property setting techniques. The syntax above that we've got here is, as I say, this descriptor syntax. And if you look at the signature of this, it'll be a little small, unfortunately. But you can see it's basically a thunk here that takes this count descriptor of stock data and will later return the iCount request. So this allows us to essentially just use this fluent sort of dot-based syntax to configure things on here. So we've got a dot index, but we could also, if we wanted to get the human readable format, we could do that, etc. So at this stage, we've sent the request. Probably get rid of this one now just so that we don't send it twice. And so something we could do on this is we could do console.writeline. What we should do, which I recommend people do, we'll just do if not count response is valid. Autocomplete was kind of good there. Sorry, if count response is valid, then we'll write this out. And what we'll do here is just say the count of documents is, and I'm just going to use the nice simple syntax here for providing the variable, and the variable will be count response dot count. So all being well, if I've coded this correctly and indeed the index is all correct, in fact, let's just see if we can do this against the alias, because that's probably better in this scenario. That should also work. So let's run the application. I'll just bring that window over here. Okay, so we can see, I can zoom this in a little bit, just drag this to a bit more of a readable size. You can see here, yes, we have the count of documents matches what we saw in our cat indices request that we did a moment ago in the dev tools. So that's a very simple way if you just want to find out how many documents overall are in a particular index. And I know that sometimes comes up as people are developing things. So what's the next thing I want to show you here? I've got my notes. So okay, so the next thing is, what about perhaps just doing a more generic, get me some of the data from the index. In this case, we're going to do an actual search here, but we'll do a very basic kind of search, which is called a match all, which basically says, give me all the documents, give me anything really. And it will do that in such a way that all those documents are scored the same. So scoring doesn't take place, because we're just saying we don't really care about the relevancy of documents. We just want whatever you've got in a particular index. So let's do search response equals await client dot search async. And again, we're going to have some options here about how we set this search up. We could do a new search request with the object initializer syntax, particularly for searches and things that get more complex, because typically searches are going to have more than just match all. You're going to be providing a query that specifies some kind of search that you want to actually perform. You'll usually perform some kind of aggregation on that data. All of that requires configuration for the search request, and I tend to prefer the Fluent syntax for that. It's not always perfect, but you know, it's the way I prefer. So in this case, let's say I'm using Visual Studio 2022 here, the latest preview, and it has this quite nice kind of autocomplete, but it's not always perfect in what it does. So I'm going to try and stop tabbing my way into that autocomplete. So I'm going to search against this index using the alias, and in this case we'll just do a match all, so we can use the shorthand match all syntax there to say, okay, go to this index. We're using the alias again for accessing this data. This is a typed, again, a generic request, because this allows us later, if we do get hits back, to actually deserialize them for you into instances of this stock data type. So that's how you to signal to us, well, what type of object do you have that represents data in the index that you're going to be searching on? And as I say, a match all is just kind of give me everything. Now, rather than spit stuff out to the console, let's just run this with a breakpoint in the application. And once that gets to the breakpoint, we'll have a quick look at what's going on there. My PC is very slow today. Okay, so let's have a look at, let's get rid of the stack trace here. And bring this in. I'll read out the details because, again, Visual Studio is quite small, probably on most screens to see this. But we can see we've got this search response. In this search response, we can see a couple of interesting things. Okay, so the first thing is we have this hits collection, and you can see this is typed to our stock data, currently contains 10. We have a shortcut into these hits through this documents property as well, and you can see each of these is an instance of our stock data type with data populated from the search response from Elasticsearch. So we've got 10 items by default. The default behavior of Elasticsearch, if you don't specify a size, which is how many documents you want to collect, it will return 10 by default, which is a sort of a suitable low number to make sure you're not causing havoc in terms of the response size. The other interesting highlight I want to make is if we have a look down here, we can see the total here. This total property is, again, a shortcut into this hits metadata object, which is the actual kind of representation of what comes back on the response. And we can see we have a value here of 10,000, but we can also see that this is greater than or equal to. So why have we only got 10,000 here when we saw a minute ago with the count that we have over 600,000 documents? This is by design. There's a setting for your cluster or for indexes that you can set called the max result window. And basically that specifies the maximum number of results that a search will try and kind of return to you or kind of search against. And that's just to stop you kind of unduly putting pressure on your server. So you can change that configuration. You can raise it if you need to. But if you want a raw count, that's why I recommend using the count API, just to get a very sort of cheap count of the number of documents. And generally when you're searching, you're not going to be doing a match all. You're going to be narrowing those results down to a subset, which will probably be lower than 10,000, but not necessarily. We may get to it today. We may get to talking about the scroll APIs, which are useful if you do want to retrieve a lot or all of the data back from an index. We'll see if we get get there in time. Otherwise, we can follow that up in the future. But generally, when you're searching, you're looking for specific subsets of your documents, not everything that we have. So we've got those values. The search response type is pretty rich. It contains all of the items that you can get to from the raw response that's coming in. We could even say, see the shard statistics here. So how many shards did this search execute against? In this case, we have one shard in our cluster. It's a single node cluster. We have one shard of the data. So that's all we searched against. And that one search, that one shard was successful. So if you did experience issues with the response, if there was some kind of error, this would maybe give you some insight into, what the failures were, which shards didn't respond, and meant that search request hasn't completed correctly. So hopefully that's clear. Let's see, no questions in the chat at the moment. So do feel free to leave any questions. If anything I'm covering, I'm going over too quickly, or it's just unclear. I totally expect that some parts of what I say could be improved. So do feel free to ask any questions. There's no stupid questions. So that's a really basic search, which we're basically saying, give us everything. So let's do something a little bit more interesting. So the scenario here, let's see what I'm going to do is, okay, so let's start by trying to work out what all of the different stock symbols are in the data that we have. So what we've done is ingested a very basic CSV containing stock data, and that was the kind of the highs and the low counts for different dates for, I think it was the Fortune 500 companies within a particular date range. Each of those stock data items has their stock symbol, so whatever their trading symbol is in the stock market as part of the data. And it might be useful if we could interrogate our data set to say, give us all the stock symbols that you have, and then we can further refine our search. So maybe we want to present those to the user in the user interface to give them a drop down when they're doing the search, or a faceted search on the left hand side, perhaps, where they can choose by sort of the facet of the category that they want, or the stock symbol that they want to group by. So we'll do search response again. Autocomplete looks pretty good there. This is going to be stock data. And again, we'll use the this fluent syntax, but or perhaps I'll show you both this time around because it might be interesting to compare. So what I'm going to do in this case is, well, let's first set the index for this as the alias again, and let's drop down here. And then what we're going to do is we're going to perform an aggregation this time. So aggregations allow us to group data in different ways. So you might want to group by unique term, is what we're going to be doing in this particular case, and say, give me all the unique symbols that you have. Other types of aggregations, maybe things like range aggregations, where you want to narrow the data down into different kind of buckets. So you might want to put your data into monthly buckets, for example, and then explore those. We can do sort of basic statistical type aggregations where we perhaps get the average or the count within those, and aggregations can be nested. So these can get quite complex quite quickly, which is why I tend to recommend people kind of figure out the aggregation using something like the Kibana DevTools, work out what is the right query and aggregation for your needs. And then it should map pretty closely to this fluent syntax. I know there are fans of this syntax. There are people that are certainly not fans of this syntax because it can get quite complex. It's something we're kind of reviewing for each new sort of major version to see if there's anything we can do to help with that. But let's have a look at the aggs that we can do here. So what I'm going to say I'm going to sort of drop into here, and I'm going to do a terms aggregation. This allows us to say group by a particular term. We need to name this this aggregation. This is just a string, so I'm just going to call this terms. Let's call it symbols. Makes more sense. And then we can provide the descriptor here for the actual terms aggregation. So we're going to do it on the field, and make sure I've got the right number of braces here. And the field we want, we can actually search into. Because this is a generic search descriptor, we know the type that you're expecting, so therefore we know the properties on it. So in order for you to choose a field from the data, from the actual index, we can actually use this. And in this case, we should have the symbol property. So I think that's pretty much all we want. The only thing I might do here is set the size. So we know our data set has lots of symbols. I actually know we've got 500, but let's pretend we don't. So let's set the size here to 1000 to collect more buckets than would be the default for the search. Now, let's just quickly run this, and then we'll have a look at how we actually access this data programmatically in a moment. So again, I'll fire this up with the debug window running. We can have a look into the search result response here. So did I do this correctly? I may have put the wrong size in here. Okay, no, we have, so again, exploring this object in this view will be a little hard to see just because of the size, but we can see that under this aggregations on the response, we have one item in the keys, which is our symbols that we defined. And the values here is a bucket aggregation. And you can see inside this aggregation, there are 506 unique kind of aggregated items. And these are our items, our terms aggregations. So these are a little bit hard to see again in this window, but we can have a look at this in a moment. But here, if we have a look at just the first item of these 506, we can actually see the key here is the symbol value, so the string value. And there's a doc count here that tells us there are 1,259 documents that have that symbol. So as I say, exploring it in this window is a little bit complicated, but that just gives you a bit of an insight into what's gone on there. So one thing I didn't do that maybe we should do is if I make sure I get this at the right point. So I want this outside of my aggregations, and if I do size 0 here, this size will control the hits. So in this case, we're actually not interested in getting documents back. And you'll have seen, let's run it again, you'll have seen in that last example when I showed you a moment ago, while we had the aggregations layer, we also had some hits, but this time the hits is 0. So we've said, actually, yeah, we just care about giving the aggregated data, and that still exists in here with this bucket aggregation, still with 506. So yeah, a little bit confusing perhaps, but this size here, which is within the configuration for our aggregation, affects the aggregation. So how many buckets we're actually going to pull back. This size here represents how many documents we want in the search results. In this case, we don't care about the actual individual documents. And we said, give us this aggregation. Now, one thing we could do just for comparison purposes, if I do request equals new search request. So this is how this would look if we use the object initializer syntax. So we could do a new search request. Let's do this. So aggregations. So we're just going to set the aggregations property this time on the actual object, and we can do a new terms aggregation. We'll call this symbols. So our terms aggregation takes the name for the aggregation, which will be that sort of abbreviated name that appears in the results. And then on here, we can do field equals. And what we could do is just provide the string. So in this case, I believe the field is symbol. But you'll see we've lost this kind of convenience up here that we had, where when we were using the descriptor, we could actually kind of use the typed field option here, this method, which gives us the ability to find actual properties on our type. And that's quite convenient in a strongly typed language. So one thing we could do here is we could do infer.field stock data. So this is a sort of a static way of doing the same. F.symbol. And then size we set as 1000. And that was on the aggregation itself. And then if I set the size on the response or on the search itself, is there. So this is the equivalent of this. And as I say, it depends what you prefer. I think once this is indented a little bit, it tends to be a little bit more readable. It's up to you which you use of these. They're functionally going to be equivalent. This approach can be quite nice. If you send the same search request over and over again, then this might be slightly more performant because you can basically save this object somewhere, create it once, and then just send the same instance time and time again. In this flow, we're always going to kind of basically process this descriptor that you provide us and actually create the underlying search request later on behind the scenes. So in this approach, every request is going to create a new search request object representing what you've asked for. But in this case, you could obviously choose to do your own caching of these and hang on to searches in cases where they're not changing per run of your application, that kind of thing. So we'll leave that there, so we can sort of see the comparison. But let's have a look at the response now on the search. Just check for questions again. So in this case, what are we going to do? We probably want to work into the aggregations, and maybe we'll just print them to the console. It's probably the easiest things to do. So let's do if not search response dot is valid. Let's just throw a new exception. Obviously in your apps, I'm sure you probably put slightly more meaningful exception messages, but this will, I'm not sure why that's unhappy. Oh yeah, it's got two of those. So yeah, if the response isn't valid, then the application will fail. You may want to do other things if the application can't make the search, but this will do for now. And then what we can do is let's actually let's get to the symbols. So equals response, search response, yeah, dot aggregations. And this is again where you kind of have to accept that we have to map quite complex JSON objects from the response back to types that you can work with. So in this case, what we do is provide mechanisms to get a particular aggregation types. In this case, we can say, well, get us a terms aggregation named symbols, if I can type. This is a perfect example of why you might want to make a constant string that you use to access that. I'm not doing that here. So that gets us into the terms aggregation, and then we can see that we can access a few things. So we can see the buckets here, which is the individual grouped items that we want. And then let's bring this onto a new line. And from those, we could count, which would give us the bucket count that we can access anyway. But what we most likely want to do is let's select these using a link that we don't have in here. So using system.link, whatever method you prefer to do this, but I'm going to do s dot, what do we want? The name, I think, on this. Is it the name? No, it's called key, isn't it? Key. So let's select each of the keys, and we'll just it doesn't matter, we'll call toList on those. That will actually evaluate that. So we said, okay, go into the aggregations on the response, look for a terms aggregation named symbols, because you may have multiple aggregations in your sets of data. From there, go into the buckets, select the unique keys from those buckets. Each key in this case will be unique because this is an aggregation on the key or on the symbol, which is the key. And then we've asked for it to a list. So I suppose what we'll do now is we do a for each var symbol in symbols. We'll just do a console.writeline. Well, let's just write the symbol out. I'll probably do for now. Just double check. Okay, so pretty basic loop there to deal with the data. Obviously, you probably do something more exciting, but let's run this code and see what gets spit out on the console this time. All right, super fast. There you go. We can see we've got all of those symbols listed there. If we had a look through here, we can see MSFT, Microsoft, being a kind of recognizable one in that data. But this gives us that those set of symbols from the data that we've ingested. So that might be the first task that you have, to populate the UI for your application with all of the symbols that someone may select. And then I guess the next logical thing would be to see if we can allow people to say, maybe get the some of the data or all of the data for that particular symbol. So in this case, I'm going to do, let's just call it symbol response so we don't duplicate names. We're going to do, again, another search on the stock data. This time, I'm just loving this autocomplete. Once it gets it right, it's not too bad. So in this case, we're going to do a query. And what we're going to do is say, what we want to do is we'll do a bool query. You can see, I think this came up last time, it's kind of lambdas all the way down here. On this one, we're going to do a filter. So we want the data filtered to a specific symbol. So filtering is basically, discard all the documents that don't have this particular value. So in this case, my filter will be on the field. Oops, sorry, no, it's a term filter. I'm going to reuse the same letter. No, that's fine. T.field field dot symbol. Too many braces here, or too few braces. We've got into the query. We've exited that. Right. So we've worked our way down. So our query is that we want to do a bool query with a filter to a term on the symbol field, and we need to provide the value that we want to sort or search for. So in this case, let's do MSFT on there. The closing brace there. So this should say, give us everything filtered down to those documents that have the symbol value of MSFT. We made that field a keyword field previously when we defined our mapping up here. So this means it's not a field that we can use full text search on. And it's basically an exact match. So in this case, we know that the symbols are uppercase. So I've used the uppercase here to create them. So if I find out where I am in here, and let's do size 20. So let's say give us the first 20 documents. And now let's also sort these. So the sort in this case, sort dot descending by the, we could do volume, maybe date. So give us the most recent items there. This is defined and will have dispatched the search. What should we do? Should we write these out? Let's do that. So if not symbol response, valid for a new exception. Oh no. So make sure the search response is actually executed, it's valid. And then I guess we could do a for each on these. Var data in symbol response documents. That's the shortcut into this this strongly typed collection of documents here. So we said earlier in our request, we're using stock data. So as I say, those will have been deserialized. So each of these now will be an instance of stock data. So we could do console.writeline. And I'm trying to think of what's in the data. So we don't care about the symbol, but let's put in the data.date. Let's put in the data.high and data.low values there. So that will do to see some data appear. I'm going to just get rid of this line here so that we don't have all the symbols from the last run, and let's run the code. Still no questions coming in, so either I'm very clear or no one has questions or people are too tired because it's hot. Could be any one of those reasons. So the app's running. There we go. So you can see hopefully 20 rows or whatever we asked for. The data, the most recent data in this case is from 2018, so that's kind of fine. And although not super clear here, you can see obviously we've got the high and low values for that particular date for the Microsoft stock. So that's a way of querying for a subset of data and taking from it the pieces that we care about based on that symbol. So that's a type of search someone may do through your application. They may say, you know, from a checkbox or a drop down, show me everything to do with Microsoft. And then we say, okay, well, here's the most recent 20 pieces of data that we have for them in some kind of table. So that's a kind of a non-full text search. We should probably get to a full text example. So the scenario I've got here, okay, so let's allow a search against a particular company name, which we'll use when we ingested this stock data. The data itself didn't include the actual company name, this name that's setting on this property here. So what I provided is a very simple lookup for the first four I could be bothered to do with the stock symbol to the company name. So when this data was ingested and indexed into the index, some of our data does have the name properly set, only for these few companies. But it's enough for us to kind of play around with. So in this case, we'll do search response. You fine. Visual Studio knows what I want to do, even if I don't. Index.alias, and in this case, the query. We could probably do a match here. So we're going to say match match dot field. And again, we're going to go into the name this time, isn't it? So we want to search against the name field with a value. Value? No, I don't. I mean query. I think, you know, there's some examples here where I'm even confusing myself. So, you know, terms aggregation uses value. Here we use query. We could probably help a little with some of the naming on some of these. So the query in this case is going to be a string that we want to search for. And I can say, well, let's imagine that our user has entered Microsoft into the search bar. We'll copy this, get the right number of those. So we'll, again, limit this down to 20 documents on a given size. We will then put these in. But maybe this time we'll write out data.name as part of the data set. This is full text response.document. Again, I will comment this one out so that we don't fill the console too much. And I'll run the code. And we're all done. There we go. So this time we've pretty much got the same data as we had before, because it's picked up those documents that have a name that contains Microsoft in them, which is kind of what we wanted. If we just take a look here, let's do an example, and I'm not sure if this is going to work, but let's do Inc. As an example. I'm not sure what the data looks like offhand. So let's run this search and just see if we get any interesting data with the Inc. scenario. Okay, it's very hard to read, but we do. So in this case, we've got a combination of results because Inc. appears in 3 of these names. And so we're having the data for those ordered again by date descending. So we've picked up different companies in our data set because we are looking for something more general that appears in more than one of those names. I won't go deep into it because I know we've got some videos and things here, but let's just do Microsoft here lowercase and just run this and just see what happens. And you can see there we've still got the data because what happens when we index documents and they get stored in the full text index behind the scenes is that those string values get analyzed and broken apart via a process of tokenization. And there's a couple of different things that happen by default, which is what's happening here. One of the things is that the individual tokens, so the individual words, are stored in the index separately. So that allows these types of searches where we said, well, give us something with the word Microsoft in it. But they are also lowercased when they go through that process, through that pipeline by default, and that's the standard behavior. So this isn't case sensitive in this particular case, but we have matched the documents we care about. And you can configure all of this in Elasticsearch itself. When you set up your index, you can define the analysis for different fields and how that should behave. This is the default behavior, which is usually what most people want. So this kind of gives us that ability to take a value and find a matching item, because most times, we're not really worried about a case sensitive match. As we saw earlier, you could use keyword fields or multi-fields where you have text and keyword mappings for the data, and in that case, the item that you want actually comes back as an exact match. So how are we doing on time? We're not too bad. I'm pretty much getting towards the end of the main bits I wanted to kind of show off today. One other scenario that maybe people are interested in is we've done an aggregation up here where we wanted to aggregate and get all the unique terms. Let's do a slightly more complex scenario where maybe we want to do a more sort of nested aggregation. So again, we're searching into our stock data. I think Visual Studio and autocomplete here. Right, index, alias name, size. Well, we're going to just do aggregations here, so we're not going to get the search data. So again, this is an aggregation where we are not interested in matching documents that might match our query. We're just interested in getting specific data. So in this case, let's do a query. What do I want to do? Let's see what my scenario was. Okay, so similar to before where we have the symbol. So I can just take this one. So let's take that query. What we want to do is aggregate this data in a particular way. Right, let's do A up here. So let's do a date histogram aggregation. So this is going to allow us to group our data into buckets, ordered or defined by some kind of date property, and we need to specify that in here, which we're going to do in a minute. We need to name this, so I'm going to call this by month. and my date histogram, I'm going to configure. Let's do that here. So in this case, the calendar interval should be, I think this takes a date time math. Actually, it's probably a shortcut to this. Bear with me, my brain engages. I think, is it date interval dot month? Our calendar interval for this aggregation is that we want everything grouped by month. The field that we're going to be doing this on is date. My code off there. And what else we want to do? We probably want to order this. I closed off too early. Yeah, I have. This is the one problem with a fluent syntax that sometimes you can run into, particularly when you're talking and not paying attention. So I want to do an order. Let's do histogram order. And in this case, we're going to do key descending. So the difference from the previous, when we did previous ordering, we sort of said, I'll just order it by the date field. In this case, what we're saying is actually order this aggregation, so the buckets that we're going to get back by the key, whatever the key is of that bucket is descending. So that gets us the buckets that I want. What I am going to do, if I again get the right location for this, is sub-aggregation. This is now, we've grouped the data by monthly buckets, and now what I'm going to do is, what's my scenario? Okay, get a sum of the trade volumes scenario. So we could do a sum aggregation in here. Trade volumes, and the sum is on the field volume. Feels like that's probably everything I want there. Get enough of these in to make everything happy. Close those all off. So again, this syntax kind of matches what the JSON structure looks like, but you know, I appreciate this takes some getting used to. If you do prefer, I'm not happy here. I've got now one too many of these, have I? Hit go to. It looks right. There we go. A bit carried away with closing brackets. Yeah, if you prefer like a different syntax, the object initializer is kind of a way of working with that as well. Just checking if we've got any questions, and looking like nothing come in at the minute. So I think this is what I want to do from a scenario perspective. I won't bother checking this is successful because I'm pretty sure it will be. So let's work our way into this data. So the first thing we want to do is access the monthly buckets. So we can do response, ag response, if I get the name right. Dot aggregations dot date histogram is what the type of aggregation we're looking for. We called it by month. And we'll access the individual buckets from that. So that gets us our monthly buckets. Just checking if I wanted to. So that's the trade volumes into the dates where they match Microsoft. Yeah, no, that feels reasonable. And then what we could do on this is for each of those buckets. So for each bucket in monthly, we could get the volume is what we've got, isn't it? Volume equals bucket. We can then get into the sub aggregation in a similar way. On that bucket, we have the sum. So this is kind of just reversing what we've done here. We created a by month bucket, which was a date histogram. Inside that, we created a trade volumes bucket, which is a sum. That's what I want to access here. And that is because it's just a sum, it doesn't contain, it's not sort of a buckets aggregation where we have placed data into groups together, which is what the date histogram is doing. In this case, it's actually just going to give us a sum of all of the data that falls in the high level bucket, so the date bucket. So in this case, I'll just get the value here. So that's our volume for the month, and then I guess we could write these out. Console writeline. So if we do the, we can get the bucket here is the monthly bucket. So if we get the date from that, and we'll get, well, let's just put the date. So that would be the date, and then we may as well get the volume. So it's like that. I think that should work. Which are famous last words. Let's see what happens. We've got some data, and it looks good. Okay, so we've got quite a lot of data there, but what we can see is the dates now they're not individual days. These are, you can see these are formatted. So day, month, year in this particular case, because I'm running on my local culture, which is UK English. So we can see that we've got, this is the February 2018 bucket. This is the January 2018 and further back. And then this here is the volume. So that's the sum of all of the volume items for all of the documents within that date. So for any trade, whichever, well, in this case, we limited it by the query to Microsoft. So for any trade against Microsoft in the month of February 2018, there were 255 million odd trades that took place. So we can see, again, you know, there were more trades against Microsoft in January, and then, you know, fewer in December. So this is a way of kind of working with that data, and there's the scenarios I've tried to show here are a kind of this last one is more of a kind of like metrics data kind of scenario where you have data. In this case, it's stock data, but it could quite easily be perhaps data from an APM system. You know, how many requests per second a website's doing. Or yeah, how many users you've had on your website, and you may similarly just want to get statistical information. You know, for a given month, show me the average number of users or the sum of all the users that are on the site, that kind of thing. And this is a very common pattern for those scenarios where we first use a date histogram style bucket to group them by date, and then we do something with that. In this case, we've limited our query, therefore the data that's going to be involved in the aggregations, to only those where the symbol is MSFT. We could take this query off and then we'd be aggregating over our whole data set, which is obviously a lot larger. But you could equally maybe do some nesting here. So maybe you actually want to say, well, give me each month, and then the sub aggregation under that could be a terms aggregation on the symbol to say, give me by month each of the symbols that had trades, and then under that you could have a sum aggregation to give you the individual trade volumes of those if you wanted to do that kind of comparison. So that's a scenario there. And looking at the time, that might well be a pretty good place to leave it. I did promise, actually, let's show one more thing. Now I can see, Andre, you've left a question that's actually going to be a really nice closing question. So I will come back to you in a moment. But let me do this last thing, which is what I promised I would do. So let me just get rid of some of these console write lines here. So earlier I said searching is obviously good if you want to search your data. So you want to, narrow the field down and look for a particular set of matching documents based on some criteria. It may be full text search, it may not be. And then other scenarios around that are that you then probably want to aggregate that data. But in each scenario, you're taking what's probably a quite large data set. In here, we've got 619,000 documents. I've worked with data sets with billions of documents in my past, and Elasticsearch is fantastic at kind of operating over those at scale. Wouldn't probably work very well on my single node low memory cluster that I'm running on Docker, but if I had a real cluster that's got multiple nodes in it, we can shard our data so that the searches take place across multiple nodes in our cluster, therefore sharing the work and kind of giving us some scaling in terms of how those perform. But all of these are narrowing down data that we've done so far. So the last scenario I guess I could show you quickly is scrolling data. So this is typically going to be if you've got an index that contains some data that you want to dump to some other source. So you want to push it out somewhere else, maybe for some kind of historical storage, or you have to interface with another system that needs the same data set, and you just want to grab it all. Searching isn't a super efficient way to do that. And as you saw earlier, we limit the search to go across 10,000 documents by default, because we don't want to create huge search contexts on the server side. So to work around that, or to avoid those kind of problems, we recommend that you get your data out by paginating through it, essentially. And you could do that yourself with the search results. What we would recommend, though, is one of two options. The more historical option that's still there today is Scroll, the Scroll API, which is an API designed for this purpose, where you can say, get me some data from this index. You can limit it to search criteria if you need to, but I just want you to give me that in batches of, say, 5,000 or 10,000 documents, and then I would just scroll that data, and you just pass it the scroll ID so that you can continue that work. And you can write that all manually in the .NET client, but it would be a bit annoying. So I'm going to show you a helper that does that. The other technique that I will touch on but not show you today is much newer, and this is something we have called point-in-time search. And this is an even more useful way potentially of doing these kind of sets or these kind of operations, where you might want to get all of the data back as it stood at a particular point in time. And in that scenario, what you need to do is open a point-in-time context with the server that gives you an ID back, and then you can search over that data efficiently using the standard techniques for getting that data back in sort of paginated form. Some of the advantages are it can be a bit lighter weight on the server end, and if you have multiple searches that you want to do, so you want to get lots of different data sets back, but as it stands at a point in time, you essentially freeze the index at a point in time, so that you only see the documents as they were when you open that point in time context. All a little bit kind of deep to kind of try and describe, so I think that would probably be an entire, or at least part of another show in the future. But let's just get to Scroll, and then we'll sort of wrap up. So what I'm going to do here, if you watch the first stream, we used a helper method called bulk all to index a lot of data, and we used its observable form to deal with accessing that data as it came back, or as we were putting it in that case, I should say. We're going to do the same on this, but what I'm going to do is use the scroll variant. So in this case, we're going to do a scroll request of type stock data. Oh yes, I need to give it some constructor arguments here. So I need the scroll time and the number of slices. So my scroll time doesn't really matter, 10 seconds. So this is how long will the scroll context be kept around after each search that this API does behind the scenes for us. The number of slices can be environment dot process account will do in this case. So this is around parallelizing the scrolls so that we actually get the data back more quickly. So we can have concurrent searches happening behind the scenes against our set of data to get more throughput, basically, because we can be sending multiple search requests behind the scenes. And in this case, I'm going to limit that to the same number of operations as I have processes, which is actually, I think, the default behind the scenes. But you know, that will do for now. And we can do. Now we can actually do the request. That's what I was trying to do before. So search. It's not happy. I think I should be in the selector here. So scroll. Oops. Yeah, I've made something unhappy. Yeah, I feel like we should be. Right. It's my own stupid fault. Yeah, I closed my method call too early. So scroll search, perfect. Right, search dot. I suppose in this case we could just do a match all. We just want everything back, and we will do max degree of parallelism to match this value here. So we said we want the scroll itself to split the data up into different sets of data that we can be querying against at the same time, and then our max degree of parallelism is how many actual requests behind the scenes we will do for you. So this is all I need to start pulling back all of the data from that index. Although I haven't specified the index, which would probably be helpful. So the index is the alias name from our index, not the whole cluster, which would be bad. And then what we can do is we can, on this scroll all observable, we can wait. And this is similar to what we did with the bulk. So we can give it a maximum runtime of time span from minutes. So let's say, well, if it hasn't got everything after 5 minutes, we'll kind of end. And the action here on this observable is going to give us a scroll all response. So after a response comes back, what do we want to do with it? And what would be useful to do with this? Probably not a lot. Maybe we just want to print the data to the screen. Let's probably kill my console here, but so we can get the search response on the scroll. So that's the raw search response, and then documents. Actually, yeah, let's do it this way. For each var doc in s doc. I need to make this a actual search response dot documents. Right. So let's go over all of the documents that we get back. Now console writeline dot. Let's just do the symbol. So all this is going to do is dump a bunch of symbols onto the screen for us, hopefully. Yeah, I think that's what I want. So basically, as I say, we've set up the scroll operation behind the scenes. Our helper here is going to issue scroll calls to the scroll API to actually handle concurrent searches across those different scrolls, blocks of scrolls that we've set up. And then we want to handle the results down here in our observer. And in this case, what we're saying is every time we get a scroll response back, access the underlying search response, which is just the same as an individual search response, but there might be more than one here, and give us its documents and then just dump them. I'm going to kick that off And we can probably watch the terminal crawl to a halt, actually, in terms of when that starts chunking through. There we go. So that's firing through now. And this is basically going to return and print out the symbol from all 619 odd thousand documents we have there. Cool. So yeah, that's me done from a kind of demo perspective. I'm just going to jump over here. So Andre left a good question, and one that's probably nice to kind of close with. What new functionality or changes are on the roadmap or planned for the library? So as a kind of standard with each minor release, what we try and do is make sure that we've implemented any new APIs that have gone into Elasticsearch itself. So in 7.13, there were some new APIs, so we added the Nest equivalents of those so that you could actually access those new APIs. So that's kind of a given with each minor release. It's quite a lot of work, I've learned, for us to kind of handle that manually, because although we have code generation for our low-level client, which does the basics for us, we typically want to have those kind of strongly typed requests and responses. And today what we do is we model those by hand. So that takes some time. And it does mean that, you know, a fair chunk of the time sort of coming up to a release could be spent building those out, building tests around those, and making sure it all works nicely. So what we're looking at for vNext, or version 8, as it will probably be, the next major to tie in with version 8 of Elasticsearch is I'm doing some work at the moment to build a new code generator. And what that code generator is going to take is a more complete specification that will be kept in sync with changes that are going into the server end, that tells us about all of the endpoints, all of the request and response models for those endpoints, documentation URLs, naming for what those properties are, potentially, you know, the actual help text that we can put as XML comments, that kind of thing. So we'll get that spec, and then we're going to build most of the high-level client, the kind of the CRUD work, I guess, the request and response models, automatically. Why that's useful is it means that it frees up our time to do deeper work on the client. So areas that I really want to focus in are performance. Obviously, the .NET team at Microsoft has done a lot of work around making .NET itself a very high performance framework and runtime. And I'd like to make sure that, you know, our client does some of the same, taking advantage of those new sort of high performance features like span of T, trying to allocate less, that kind of stuff. So that, by doing the kind of code generation, that frees us up to spend more time in the future looking at those kind of things, performance being one of them, helpers being another. So today I've shown you the scroll helper, or the scroll all helper. We looked at bulk all previously. Those are helper methods that try and sort of encapsulate a set of methods or a set of operations you might need to perform on the server that you would commonly perform as part of a larger piece, like scrolling, or like bulk ingesting data. So areas that sort of jump to mind that I've already started planning for are things like the point in time stuff that I mentioned. Rather than you having to send a request to open a point in time context, then search against it, then when you're done, remember to close it. We could certainly make a helper that allows you to kind of get a disposable context, which will be the point in time context, through which you send search requests. And we just then ensure that any search requests within that context will be sent to the same point in time. And when that thing is disposed of at the end, we could close the point in time on the server. So that frees up server resource. So there's those kind of sort of helper methods that I want to focus on. And because we're doing code gen in V8, it does mean naturally there's going to be some churn and change between some of the APIs that we have today in terms of the request response models, because we're going to be using the spec and we're going to try not to diverge from the spec. There will be some that will, there we go. We've just finished 619,000 items have been scrolled out of the index there and written to the console. But yeah, so as that spec will give us the namings, it will mean that all our clients are more consistent in terms of naming. So if you're jumping occasionally between the .NET client and the JavaScript client, you'll be able to use the same names for things, and you'll know what those mean. But it will mean that some of the names that we've used historically might change a bit. So that's one thing that we need to try and deal with. But it does mean that because we're making quite a big change, this is going to be quite a divergence in the client's history, because it will be predominantly code generated. It means that we can go and take a look at some of the other decisions that have been made in the past that people maybe have complained about or aren't super keen on. So can we make the Fluent syntax easier to work with in some scenarios? Can we provide shortcuts for common scenarios that people are working on? All of those kind of things are stuff that I'd certainly like to look at, with the goal of making the client more usable out of the box for people that are less familiar with it and for those that are more experienced with it. So that's kind of my plans. In terms of, I guess my ask to the community here would be, if you've got pain points today with the library, there's bits that you don't like using, or you don't understand, or you think that could be improved, particularly if you've got a suggestion for how you would like it to be. In particular, that'd be really useful. I'd welcome those from you. So my DMs are open on Twitter at Steve J. Gordon. If it's a short type of thing that you can kind of get across in a Twitter DM, feel free to ping it there. We can open a dialogue, and we can always follow up offline by email or something later on. If it's more of a API suggestion or just a usability issue that you think could be improved, feel free to open an issue in the GitHub repository. If I bring that up here. So here's the Elasticsearch net repository. So it's under the Elastic organization, Elasticsearch-net. This contains all of our code, and obviously here are the issues. So you can see some of the stuff we're thinking about. As I say, these API designs are things that I'm thinking about. So feel free to propose stuff here. It doesn't have to be fully formed. It can just be, this is painful. I'd prefer if I could use it like this. And we can kind of take those things on board. One of the ones that's kind of bubbled up again today, I think people are having issues with, is whether they can use the source serializer on parameters of scripts, which isn't the case today, and is a very good issue to raise with us now, because we can kind of take a look at that. If it's something we can't implement in 7x because it would be a breaking change to current users, we can make breaking changes in 8. Obviously, breaking changes are never ideal, but I think sometimes it's worth making a breaking change to make the product better for people going forward, and a small amount of upgrade pain that we can try and sort of reduce as much as possible. And so that's the opportunity where some of this stuff might have to kind of happen in that 8.0 timeframe. So this is a really good time to bring them up while we have that opportunity. Cool. I think that's all of the questions. Hopefully, Andre, that answered your question. They're the kind of things I'm thinking about for it at the moment. In terms of the demo I've shown today, I have this is the repo that I've got for it here. So this is on my own repository under my own account on GitHub. So it's DJ Gordon on GitHub. Elasticsearch-examples. This is at a state prior to what I've just shown you. So what I'll do in a minute is push up. I'll probably create a branch and push up a session 2 branch or something. And then you'll be able to go and pull that code down. But if you want to have a look at what we've covered today, you can do so there. And that's pretty much what I had for today. So yeah, I guess Faith, is there anything else that you wanted to to bring up or questions that you may have had?
No, I don't think so. Thank you so much, Steve. That was super informative. And thank you also for linking to your GitHub. I know folks really appreciate that. And just thanks again for your time today. And I'm sure we'll be seeing you soon. All right.
Yeah.
Thanks,
Thank you very
folks.
much.
Bye.